Hello and welcome to the Data Structure and Algorithms online tutorial video. In the last video we saw what is binary tree, and in this video we will discuss about the binary search tree. In a binary search tree, the value of the left node must be smaller than the parent node and the value of the right node must be greater than the parent node. This rule is applied recursively to the left and right subtree of the root. We will understand the concept of the binary search tree with an example. We can see that the root node is 25 and all the nodes of the left subtree are smaller than the root node and all the nodes of the right subtree are greater than the root node. Similarly, we can see that the left child of the root node is greater than its left child and smaller than its right child. Therefore, the tree shown here is the binary search tree. Suppose if we have to change the value of the 22 to 44 in the tree, check whether the tree will be the binary search tree or not. In the tree, the value of the root node is 25, which is greater than its left child 20, but the smaller than its right child 20, that is 44. So, if the tree does not satisfy the property of the binary search tree, therefore, the tree shown here is not a binary search tree. Let's discuss the advantages of the binary search tree. Compared to the array and linked list, insertion and deletion operations are faster in the binary search tree. Searching an element in a binary search tree is easy, as we always have a hint that which subtree has a desired element. Now let's see one example for understanding the binary search tree thoroughly. We will consider an example of numbers. Out of this array, the first number 9 will be inserted in a tree as a root node. Then read the next element and the next element is 4. As 4 is smaller than 9, it will be inserted as a root of the left subtree. And read the next element, that is 11. And 11 is greater than the root node, so it will be inserted as a root of the right subtree. Next is 2, and 2 is smaller than the root value, so it will be inserted in the left subtree, and in the left subtree we have already inserted 4 as the root of the left subtree, and 2 is less than 4, so it will be inserted as a left child of the left subtree. Next is 7. 7 is less than the root, so goes to the left subtree, and it is greater than 4, so it will be inserted as a right child. 8 is less than root, so goes to the left subtree, and it is greater than 4, so goes by right child, and it is again greater than 7, so inserted as the right child of 7. 15 will go in right subtree as it is greater than the root node, and it will be inserted as a right child of the root node of the right subtree as 15 is greater than 11. Now the last node 14 will be inserted as the left child to the 15. We will see the operations that can be performed on the binary search tree. We can perform insertion, deletion and search operations on binary search tree. We saw till now how to insert the elements in the tree. Next we will see searching. Finding or locating a specific element or node in a data structure is called searching. Searching a node in a binary search tree is easy because elements are stored in a specific manner. Let's see the steps involved in searching the node in a binary search tree. Compare the element to be searched with the root element of the tree. If root is matched with the target element, then return the node's location. If it is not matched with the root node, then check whether the item is less than the root element. If it is smaller than the root element, then move to the left subtree. Move to the right subtree if it is larger than the root element. Repeat the above procedure recursively until the match is found. If the element is not found or not present in the tree, then return null. Now let's understand the searching in binary search tree using an example. This is the tree we have formed. Let's consider an element to be searched is 7. Root node is 9. First we will compare 7 with the root node, and 7 is less than the root node, so search in the left subtree. Root of the left subtree is 4 and 7 is greater than 4, so we'll go to the right child, and here we found the element. Now let's understand how deletion is performed on the binary search tree. While deleting an element from the binary search tree, we must keep in mind that the property of the binary tree must not be violated. There can be three possible situations that can occur while deleting node from the binary search tree. The node to be deleted is the leaf node, or the node to be deleted has only one child, and the node to be deleted has two children. We will understand these situations one by one. Deleting a leaf node. It is simple to delete a node in a binary search tree. It can be done by replacing a leaf node by null. Suppose if you want to delete node 40 as it is a leaf node, we can replace the node 40 by null and free the space. Deleting a node having one child. In this case, we have to replace the target node with its child and then delete the child node. When we replace the target node with its child node, the child node will now contain the value to be deleted. Simply we have to replace the child node with null and free up the allocated space. Suppose if we have to delete the node 36, as the node to be deleted has only one child, so it will be replaced with its child 30. So the replaced node 36 will now be a leaf node that can be easily deleted. In the next video, we will discuss about the AVL tree. Please like the video, subscribe to our channel, and please hit on bell icon to get notified whenever we post new videos. Install DSA application from the Google Play Store or from the link given in the description below. Please let us know if you have any queries in the comment section below, and thank you for watching.